is the SL and 21 paper, and these are just the extra SL questions that I didn't cover in HL. So definitely go check out the HL playlist that has most of the SL questions as well. So question 1 was not there. What is a vector quantity? Acceleration. That should be pretty quick. Topic A, by the way, the answer is not necessarily A, but the answer is A. A ball of mass, we did that one. 4, question 4. This is topic A again. A ball is thrown vertically downwards with an initial speed of 4 meters per second. The ball hits the ground with a speed of 16 meters per second. What is the time of fall and what is the distance traveled by the ball? Okay, so we have, let's write our formulas. We have hits the ground with a speed, so we have v and we have u, so v is equal to u plus at, and we're trying to find t, so let's find t. T is v minus u over a. 16 minus 4 divided by acceleration is, let's just say 10, right, g, so 12, 1.2, so that's either of these two. And then we have distance traveled is s is equal to u plus e, sorry, let's use a different one. We can do v squared is equal to u squared plus 2as, and that gives us s is equal to v squared minus u squared over 2a, and that is 16 squared is 256, right? And then minus 16 divided by 2 times our acceleration is 20. And so what we have is 240 divided by 20, that is 12. And so our answer is D. And that's correct. An elevator and its load accelerate vertically upwards. And we have which statement is correct in this situation. Net force on the load is 0. It's accelerating, so that is not the case, right? The tension in the cable is equal but opposite to the combined weight of the elevator and its load. Tension in the cable is equal but opposite to the combined weight of the elevator and its load. That's basically saying our F net is equal to tension minus our weight is equal to 0, which means there is no acceleration. In fact, it should be equal to ma, but they're saying it's equal to 0. So this is the true system, so that's why this is wrong. The normal reaction force on the load is equal but opposite to the force on the elevator from the load. It's equal but opposite to the force on the elevator from the load. Yes, right? So what we're saying is there's a normal reaction force from the elevator on the load, and now we're saying equal and opposite to the force on the elevator from the load. So there's an equal and opposite reaction here, and so C is our correct answer. And let's check D. The elevator and its load are in translational equilibrium. That is false, right? We have an acceleration. That means it's not in equilibrium. And now we did this one. This one is topic A as well. An object of mass 1 kg hangs at rest from a spring. The spring has negligible mass and spring constant 20. What is the elastic potential energy stored in the spring? So we have EP is equal to half a delta x squared, right? And have they given us, they have not given us x, they've given us the mass, spring constant, okay, elastic potential energy. So we do know that it should be equal to mgh, delta h, and that change in h is equal to our change in extension, right? And so we have fk x. In fact, I think we should do net force first, right? Because it's at rest. So we have F net is equal to our weight, which is downwards, is equal to our Hooke's or elastic potential, which is Kx, to mg, and that way we can find x, right? So mg is 10 divided by 20, and so we have 0.5. We can put that back in here, so we don't even need this. What we have is 0.5 squared, and our k is 20. Right, so that is 5 cubed, essentially, times 20. That is 2.5, right? That is 2.5, and so our answer is B, and that is correct. Hopefully that made sense. Let's see if there's any more topic A's. We did this one. Okay, and the rest are topic B. So we can B, C, D, and E. So we'll come back to that. Hope this was helpful. Please do like and subscribe, and go check out the playlists for everything else, and hope this helps.